Hey guys, welcome to my channel and today I'm recording Cambridge O-Level 5070 paper 2, May June 2021. This is a theory paper. I've already solved its part 1 and part 2. You can check it out in the link in the description below. I have put the playlist link. So without any further ado, let's get started with our part 3 video. We've already solved till question number 4 and today we need to start question number 5. Question number 5 says petroleum crude oil provides the raw materials for making ethanol and ammonia. Part A says describe how petroleum crude oil is separated to make fractions such as naphtha and petrol gasoline. So here we're supposed to brief a little about fractional distillation, and first of all you need to write that crude oil is heated. After it, fractional distillation process is used. That means there's a fractionating column in it. And after it, on the basis of their different boiling points, um, all of these are getting separated. For example, naphtha and petrol will get separated on the basis of their boiling point, and then the fractions move up in the column at different rates due to their boiling point. Alright, you can also mention a little about condensation. However, it is just for 2 marks, so I'll suggest to keep it minimal but complete. Moving on to part B, compounds such as ClH24 and naphtha fraction are cracked to make hydrogen alkenes and smaller alkanes. Explain how molecular formula C11H24 shows the compound is an alkane. So basically, if we talk about alkenes, alkene has this general formula that is CnH 2n plus 2. And if we look at this formula, so it's more like C n, where n is 11. Alright, you can also do it in this way. If we consider n as 11 and 2n plus 2, which is 2 into 11 plus 2, so it is going to form C11H24. So because it follows that general formula, it is on that general form as it follows that general formula, so that is why we can say it is an alkane. Alright, moving on to part 2, construct an equation to show the cracking of ClH24 to make ethene and alkane only. In this cracking process, we are basically cracking ClH24 and we are making ethene out of it and we are making an alkane out of it. So how are we going to do it? Let's construct the equation. So this is how I have constructed an equation. You can construct a different equation, but you need to make sure that you have ethene over here and then you have an alkane over here too. All right, so that is how it's going to be done. Moving on to part C, describe how hydrogen is converted into ammonia in the Haber process. Include the condition used in Haber's process. So basically, in Haber process, we do the reaction with nitrogen. All right, and the conditions are, first of all, for condition you need to remember to mention the temperature, to mention the pressure, and if any catalyst is used, you need to mention that too. In case catalyst isn't used, of course, you do not need to mention it. However, make sure whenever we're talking about condition, these three things hit your mind, which is pressure, temperature, and catalyst. So, if we talk about pressure here in this Haber's process, we have around 200 to 400 atmospheric pressure, and then we use a catalyst iron Fe, and the temperature is around 400 to 500 degrees Celsius. So, this is how you're going to write it over here. Alright, and we can describe a little about it, that here the reaction has taken place with nitrogen, and you can mention about the conditions and all. It's just a 3 mark. However, since the question says to describe, you may describe it too in a little, in a line or two, the reaction. Moving on to part D, state one other use for hydrogen. Hydrogen is used in fuel cell. Alright, Like it was used in Haber's process. In this way, it can be used in fuel cell. It can be used to make margarine, if you know hydrogenation. In that we studied all this. Moving on to part E, ethene reacts with compound to make ethanol. Name the compound. So ethene reacts with a compound. Here we are talking about ethene's reaction with a particular compound. Which compound is unknown, that we need to figure out, and it is forming ethanol. So if we look at it, um, if we, I'm sure you must have gone through the reactions in organic chemistry chapter. So whenever we react ethene with water, we get an alcohol. Or like not ethene with water, but if we do alkene plus water, so it's going to give us an alcohol. Likewise, over here, if we talk about ethene, ethene will be reacting with a compound. Um, and that compound is going to be water, of course, because we're getting ethanol as a product. Moving on to part two, name one condition for this reaction. Of course, for every reaction we have a condition. So for this, we can say that catalyst is a condition. We need to have catalyst for it. You can mention other conditions too. For example, high temperature. The water must be at high temperature. The whole reaction must take place at a high temperature. Alright, so that's it for question number 5. Moving on to section B, question number 6. Sulfur dioxide and oxides of nitrogen are pollutants found in air. Part A says, state one environmental problem caused by the presence of sulfur dioxide in the air. Sulfur dioxide in the air can cause acid rain, which is a huge problem. You can write acid rain. Moving on to part B, uh, also about sulfur dioxide, since it's a one mark, you do not need to write a lot about its process, that how it affects the environment. However, I'll give you a brief background since we are talking about it. So sulfur dioxide reacts with the environment, the oxygen in the environment, the water with the environment. That happens when rain is taking place. The water that is there when it's raining. So it produces sulfurous acid, then sulfuric acid, and we all know sulfuric acid is really harmful and is an environment causes environmental problems. Alright, so this is how it is. This is how sulfur dioxide affects the environment in brief words I just told you. However, you just need to mention in one word that it's acid rain. Moving on to part B, coal-fired power stations produce sulfur dioxide as pollutant. The sulfur dioxide produced is prevented from entering the air by a process called flue gas desulfurization, that is FGD. Name the compound used in FGD that reacts with sulfur dioxide. The compound is calcium carbonate, alright, for the desulfurization process. Moving on to part C, coal-fired power stations also produce oxides of nitrogen such as NO. NO is produced when nitrogen reacts with oxygen. Construct the equation for this reaction. So basically, we have nitrogen over here, we have oxygen over here. These are our reactants. And if we talk about our product, so this is the product. So now we need to construct a balanced equation. The balanced equation for this will be N2 plus O2 is equals to why is it, alright, so it is equals to NO. However, we need to balance it, so it's going to be 2NO. The equation is now balanced. Moving on to part 2. Draw a dot and cross diagram to show bonding in a molecule of nitrogen only include the outer shell electrons. So we need to show the molecule bonding of nitrogen, that is N2, and we are only supposed to mention the outer shell electrons in it. Alright, so for this, let's start drawing it. So this is how we are supposed to draw it. Alright, so basically nitrogen has 5 in its outer shell electrons. Outer shell electrons are total 5, And that is how we've drawn it. We are showing the sharing of electrons over here basically, and yeah, that's how you're supposed to draw it. Pretty simple. Moving on to part 3, explain why the rate of reaction between nitrogen and oxygen increases as the temperature increases. So basically, when temperature increases, the particles gain kinetic energy, due to which there are more successful collisions taking place, hence the rate of reaction increases. Moving on to part D, nitrogen dioxide NO2 reacts with water to form a mixture of dilute nitric acid HNO3 and dilute nitrous acid HNO2. Nitrogen dioxide reacts with aqueous sodium hydroxide to form two different salts and water. Construct the equation for this reaction. Um, the equation for this reaction will be in such a way. Let's first of all highlight. So we have our reactants are nitrogen dioxide, which reacts with aqueous sodium hydroxide, and it forms two different salts and water. The main thing over here that we need to do is identifying the two salts. So let's draw the equation and identify them. So this is how we're supposed to construct the equation or balance it. If we balance it, it's going to be in this way. And alright, yeah, so it's balanced. Over here we have our salts. These are the two different salts as per the requirement of the question. And the reactants are over here. So this is how you're supposed to do it, and this is water. Uh, that is also a product. Alright, so moving on to part 2. Nitric acid is a strong acid, nitrous acid is a weak acid. Describe the difference between weak acid and strong acid. When we're talking about strong acids, that means they completely dissociate and they completely ionize. However, weak acids partially ionize. They have incomplete dissociation of hydrogen. Basically, they partially ionize. You can also mention in short words that strong acids completely ionize while weak acids partially ionize. Alright, so that is how we're going to get 2 marks very easily. This is it for this paper. I hope you found it helpful. I'll be solving more questions from this paper in the videos ahead. Make sure to subscribe, ring the bell icon to stay updated with all the videos I post. That is it for this video. Thank you so much for watching and best of luck for your exams.